Well, welcome to MV Tutors. If you would like a private session with us, go ahead and visit our website, book the session there. You'll find our website under the description of this video. All right. Okay, get a let's get ahead and discuss the differences between carboxylic acids and esters. Okay, there are subtle differences between these two, but let's go ahead. Let's start by describing the carboxylic acids. Carboxylic acids. So these are just acids, but they are carboxylic. There's different types of acids. What makes these ones carboxylate is the functional group, which has carbons in it. So functional group of this one is just C, okay, and then you will have an OH over there, and then you will have an O over there. Okay, that's it. That's the functional group. Now let's talk about the next thing to discuss is actually the structural example, structural formula. So let's take 1, 2, 3. Okay, and then we have 3 carbons here, and then we'll put our O there, and then we'll put our OH there. Okay, so the rest of these, they have H's in them. And then let's just take another example. Let's take 4. 1, 2, 3, 4 of them, and then we'll put an O and then an OH. Okay, now an O is always has 2 bonds. So this one has to have 2 bonds. This one has to have 2 bonds. This one, let's just remove that and put it like this. It has to have 2 bonds. You can also put it an OH like this. It has 2 bonds, so it's got one on the left and one on the right. Okay, so and all of these have 4. Okay, so carbon has 4 bonds, oxygen has 2 bonds, hydrogen has 1 bond. Okay, now that's it. Now let us discuss the naming of this. Okay, so the suffix, as you can see here, is oic acid. Okay, oic acid. Right, so as you can see, this 1, 2, 3, that's a prop. Propane, it's a prop, and then you put the suffix oic acid, propanoic acid. This one, 1, 2, 3, 4, it's a bute. Right, it's a butane, so it's a bute, and then you put the suffix oic acid. Right, now let's go ahead and discuss the condensed structural formula. All right, so it comes from the structure, okay, of this thing. So as you can see, the structural formula of this propanoic acid, from the left, this C, the first C, has 3 H's attached to it. The second one has 2 H's. The third one, okay, the third one has an O, which is double bonded, and then an OH. Okay, so that's how you name that one. And then now we need to take a look at the butanoic acid. So it's the first one has 3 H's, second one 2, third one 2, fourth one has an O and an OH. That's how you do the condensed structural formula. And the last thing to discuss with this acid is the molecular formula. Okay, so with this one you count the number of C's. So we've got 1, 2, 3 C's. How many H's do we have? We've got 3, 4, 5, 6. And then how many O's? We've got 1, 2. That's it. Okay. Now this second one then, you can also count it from the structural formula. 1, 2, 3, 4. We've got 4 C's. Let's go ahead and count the number of H's. 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 H's. And how many O's? Let's go ahead and count them. 1, 2 O's. 2 O's. That's it. Now let's go ahead and discuss esters. Esters. Now the functional group for esters, if you've got a C, you've got an O there, and you've got an O there, and something else there, and another C there. Okay. Let's just make an example. 2 examples of structural formulas. So let's say we have C, 2, and then I'll put an O, and then I'll put O there, C. Okay. Well, obviously it's got H's there. Now let's say I have 4 of them now for this one. 1, 2, 3, 4. I've got my double bonded one over there, which means we won't have any there. Okay, so we'll just have a C there. Cool. Now, let's talk about the naming of these things. Right. So, the suffix, we've got 2 suffixes on this one. We've got a Y and also an O8. Is that how you spell O8? Let's go and see. That's right. Okay, so in naming this one, this is actually how you spot the difference. With the Y, you look at, see, we've got 2 O's here. We've got the one that's double bonded and the one that's single bonded. Okay, so with the single bonded one, which is this one, you look how many, you start with how many C's does the single bonded one have? It has 1. So 1 is meth. So that makes it a methyl. Meth, and then you put the suffix I. And then now you go to look at the double bonded oxygen and see how many C's it has. Now this one has 2 C's, which makes it, if me is 1 C, then eth is 2 C's. So it makes it an ethanoate. Ethan, it's an ethan. And then you put the suffix O8. Okay. Now let's take a look at this one. Same concept. we look at the single bonded one first. The single bonded one is that one. So how many C's does it have? It has one. So it's also a methyl. It's a meth, and then the suffix thyl. And then you go take a look at the double bonded O. It's got 3 C's. So that makes it a propane. And then you put the suffix O8. So that makes it a methyl propanoate. Okay. Now that's the naming of it. Let's take a look at the condensed structural formula. Structural formula. Okay, there we go. All right, so as you can see, I want us to count it here actually. I want us to count it here. Let's look at this. The first one, the first C has 3 H's. The second one has an O and a O. So it's COO. Okay. And then this C here then has 3 H's. Okay, it's got 3 H's because remember it must have 4 when it's complete. So that's the condensed structural formula for that one. Let's look at the methyl propanoate structural formula. The first C has 3 H's. The second one has 2 H's because there's one over there. The third C has an O and an O. And then the fourth C has 3 H's. Now, the big difference between an ester and a carboxylic acid is basically the functional group, where the functional group is. Now, typically, a carboxylic acid has the functional group at the end of the chain. Okay, you see, it's at the end of the chain, while a ester has the functional group in the middle of the chain, somewhere in the middle of the chain. That's why it has 2 suffixes. So it can be on the second. If you've got 4 chains, then it can be on the second or third. If you've got 5, it can be on the second, third, or fourth, but somewhere in the middle, not at the end. Once the functional group is at the end, then it's no longer an ester, but it's a carboxylic acid. Otherwise, they both have the same molecular formula. Okay, because if you check out the molecular formula for this one, okay, let's just say molecular formula. Okay, if you count the number of C's on this one, it's 1, 2, 3 C's. If you count the number of H's, you've got 3, 6. And then the number of O's, it's 2. This side as well, how many C's? We've got 4 C's. Number of H's is 3, 5, 6, 7, 8. We've got 8. And how many O's? 1, 2. We've got 2. Now, if you look at the molecular formulas, they are basically the same, okay, of an ester and a carboxylic acid. The difference is just where the functional group is. Once the functional group is in the middle, it's an ester. Once the functional group is at the end, it's a carboxylic acid. That's it. Thank you very much.